video on how to make it work, how to take advantage of this technology, and how to make money out of that. So we'll kick it off. The presentation will be shared at the end of this session in one of the follow-up emails. You can, during the session, you can raise your hand, you can ask questions here in this tool, in the GoToMeeting, and we'll handle all the questions at the end of this session. Let's go. Okay, so the first question that you're probably asking yourself, 5G is the play of the big guys. So I'm not Verizon and I'm not AT&T, so what I'm going to do, what is there for me, what I can do with this buzzword 5G in order to make my business growing? What is the value for smaller service providers that are not willing to pay an arm and a leg for a license bands, to spend billions of dollars to acquire those bands and still take advantage of this technology in order to stay competitive, in order to deliver better services to their customers? And this is what we are going to do. This is what we are going to do today. We'll show several models that work in urban environments as well as in suburban environments, and hopefully it will be beneficial for you, and you can learn how to implement that in your own network. So I'd like to start with the Spire. They lately announced that they are going to deliver affordable 5G internet to homes and businesses in Mississippi area. You can see here on the right hand side, this is their promotion site where people can check for whether the service is available in their region, and also learn about the service. So they deliver high-speed internet to homes and businesses. Everything is for $50, no matter whether it is a business or a single-family home. There is no contract, there is no obligation, there is no credit check, there is no credit score, no installation fees. Everything clean, simple. People just sign in through the internet, through their portal. Once they have money to pay, they get the service. If they don't have money to pay, they are disconnected. And they plan to scale this offering all through Mississippi area. So if it can work in Mississippi, and they plan to cover 80–90% of all the state and consider to take it to other states later on. So probably this is something that can work nationwide as well. So for the time being, they use a combination of fiber, millimeter wave, and sub-6 technologies in order to implement this solution. And this is where they are. Another example is from the urban side of the market, and Webpass. Webpass is probably the most famous wireless internet service provider. Webpass was acquired by Google Fiber about 1.5 years ago. They specialize in providing internet connectivity in urban areas. They serve 7 metro areas. And this is a snapshot of San Francisco. You can see on the left-hand side how dense the network is. And on the right-hand side, you can see that they actually, according to the speed test, which is an absolute kind of KPI for the quality and the speed of the internet connection, they outperform all the incumbents in this area. Okay, so not just in the uplink, but also not just in the downlink, but also in the uplink, which is also starting to be really important today. Now, they are doing that without compromising on the quality of service. You can see here that their Yelp rating is 4.5 stars, which is very, very, very good for a service provider. Now, this is another metric to emphasize the quality of the network. By the way, Webpass network is built 85% on millimeter wave radios. They mostly serve MDUs and businesses, and they have some fiber, and they use millimeter wave to extend this fiber. And as you can see here, this is a snapshot of YouTube metric, and here you can see at the peak hours what percentage of the stream is HD quality and what percentage is SD quality. Okay, so the more capacity you have in your network, the better your latency is. You'll end up with delivering more HD content. Now, at the top of the screen, you can see that that Webpass provides 98% during the peak hours, 8 to 9 p.m. They provide 98% of all the streaming in HD quality, and compare it to a fiber service provider, which is 100% fiber in the same area. Actually, Webpass, using this hybrid fiber wireless network, fiber plus the millimeter wave, they outperform service provider that uses 100% of fiber network. Okay, Sonic at the bottom here, they are capable of delivering just 94% of all the traffic in all the YouTube traffic in HD format. Okay, so this is 5G millimeter wave technology is actually about how to deliver that, how to implement the net, how to build your network using this technology without compromising neither on quality nor on performance. To sum up the introduction here, so we've seen a service provider, a sizable service provider, Spire, that took this technology to the rural America. We've seen an example of Webpass. By the way, the cost of service for Webpass, the price for the service is about $60, also no contracts. And from consumer perspective, this is how the internet service should look like. Affordable, no contracts, no obligations, simple, clean. And we've seen Spire once again able to deliver it in the rural parts of America. We've seen Webpass example that are able to deliver it in the metro areas, major metro areas here in the United States. We have other examples as well, but the point is that still the fixed wireless access market in the US is heavily underserved, and it represents very big opportunity. So if we analyze all the buildings, all the structures here, we see that structures that are in main suburban areas or in main areas and that are within close proximity to fiber, but not connected to fiber, these are the numbers: 60 million of single family homes, 4.5 million of MDUs, and more than 2 million of commercial properties, commercial buildings. So the discussion here is how to take this technology, how to take this 5G and to unlock this market opportunity. So what is there for me as a service provider? Others are successful in doing that. So others like Spire, Webpass, and many others, they learn how to take advantage of this technology and make it profitable, make it scalable. There is no compromise on the performance. It's not kind of it's not a low performance CAF initiatives that are being taking place here in the United States. This is something that you've seen that Spire, they offer 120 meg service. Webpass outperform all other incumbents, delivering on average something around 400 megabit symmetrical service. So this is the performance. So this is something that people will need. So this is the level of service that people that customers are expect, and this is something that will make you or will keep you competitive on the broadband market. The market is underserved. We've seen the numbers for unserved properties or properties without fiber, where the 5G technology can bridge the gap. And this approach is scalable. If Spire figured out how to take it statewide in Mississippi, probably it can work in all other states in here. Now let's talk business. So the agenda is to understand the business case for this technology, to choose the right frequency, because there is a lot of confusion about 5G. What is 5G? What frequency is used for 5G? Sub-6, licensed millimeter wave, unlicensed millimeter wave. So we try to review that and select the right one that will make the business case work for you. We'll talk about solution. There is no one side that fits it all. You need, as a service provider, you need to think about solution, because there are a lot of use cases. There are some installations that will take place on the poles, rooftops, residential rooftops, high-rise building, etc. We'll talk about that. How to reduce the labor cost and the truck rolls. When you go and analyze the business case, you'll see that a huge portion of the business case, and in some cases, the labor can cost more than the equipment cost. So we'll talk about some ways to how to reduce that, how to plan, and how to how to build a reliable network that the maintenance cost will be also lower. And also we'll give you some hints about advanced tools that you can use in order to plan the network, in order to calculate the business case, in order to anticipate the performance, etc. So this last topic is also very important. So just to sum it up, what it boils down to, it goes to how to reduce the total cost of ownership of the network. What steps, how much money do you have, and how to make it work within this budget. So the first question is, how much money do I have? In today's competitive world, the average revenue per user is about somewhere between $50 to $60 per month. Google Fiber set a bar of $70 per month. So probably in some cases, in some neighborhoods, people will be willing to pay $70, $80, but in most of the areas, people will compromise on speed and would like to pay less for the internet service. So we've seen that Spire, they charge $50 for a 120 meg connection. Webpass, they charge $60. So let's assume that the average revenue per user is $55. The gross margin is about 80%. It means that the total net revenue, and assuming that the ROI is 2 years, it means that the total net revenue from a customer is about $1,000. So it just 2 years multiplied by 12 months, multiplied by $85 per month, and taking 80% out of that. So it means that in order to connect a customer, and in order to be profitable within this ROI period, you need to spend no more than $1,000 per customer, and it should cover the labor cost, it should cover the central office cost, it should cover the backhaul, and it should cover the access part or in-building connectivity when we talk about MDUs. And okay, so this is the budget that a service provider has in order to connect the customer and make it profitable. Now, what technology should I use to deliver this 5G internet? So the performance is very important. We will define three KPIs here, and the performance is really important because it what help you it helps you to be competitive, because at the end of the day you'll not survive as a service provider delivering 10 megabit or 15 or 20 megabit to a customer, because you need to compete with other players. Mainly, you probably compete with DOCSIS guys. MSOs, they rolling out DOCSIS 3.1, and DOCSIS 3.1, at least on the paper, is a technology that is scalable up to delivering up to 1 gigabit per second per home. Yes, everything is aggregated, it's not symmetric, but the marketing perception is that the DOCSIS is something that can deliver hundreds of megabits per second. It means that when you choose the technology to deliver 5G internet, you need to think of technologies that will give you the performance that will help you to stay competitive. It means hundreds of megabit per second today, and something that will be scalable, that can grow to gigabit service later on. Business case, we've talked about it in the last slide. You have a budget of $1,000 to connect the customer, and the technology that you use should be able to fit into this budget. Access to the spectrum. Not all the spectrum is accessible, at least here in the United States. There are some bands that require licenses, and we'll talk about that in the next slide. And you need to ask yourself what band, how much money do you have, what band is really something that that is accessible to you. So comparing those three KPIs, I'll try to make it simple for different fixed wireless technologies, and the technologies that have chosen here, or simplified the spectrum. These are the sub-6 bands. These are the licensed millimeter wave frequencies, like the 28 and 39, and there are unlicensed and lightly licensed millimeter wave bands. Okay, so let's start from the performance, from the first KPI, which is the performance. We've talked about performance as the technology should be able to deliver hundreds of megabits today. So sub-6 really struggles with that. I don't think that there is a reliable technology today that operates in sub-6 band that can deliver hundreds of megabits. Definitely not something that will that is scalable to a gigabit service. So sub-6 as a standalone technology does not comply to the performance KPI. Licensed millimeter wave frequencies, we've seen a lot of trials going on by the big vendors, by the big carriers. Verizon, AT&T, they tried those 28, 39 bands, and they definitely showed performance that can deliver gigabits per second to the end user. So in terms of the performance, there is no problem with the licensed bands. And of course, unlicensed 60 gigahertz and lightly licensed 70-80 gigahertz. There is huge amount of spectrum in those bands, and there is no problem to deliver gigabits, even multiple gigabits per second to the end users with the technology available today. From the business case perspective, this is our second KPI. Sub-6 technology today can definitely meet the business case. This is field-proven, steady, and pretty much and technology is pretty much a lot of time in the market. So this is the ecosystem for the sub-6 technology is based on consumer electronics, primarily Wi-Fi chipsets, and there is a huge economy of scale there, and the equipment is pretty cost effective. So from the business case perspective, this technology, the KPI works here. If we examine the business case KPI for the license bands, it's not there yet, and the big question mark is whether it is going to be there at all, because currently there is no, despite the buzz and despite all the announcement of big vendors, today there is no ecosystem for the component in this in license band, in millimeter wave license bands, and also the cost of the core network, which is based primarily on LTE, is also huge. So the cost of the central office equipment is very high, and therefore the business case KPI doesn't work here. And for the V band and E band, the business case works. The technology is also based on consumer electronics. There is economy of scale there as well. So there is no problem to meet the business case there. Now, the last KPI is the availability of the spectrum. Today, sub-6 bands are available. Most of the bands are unlicensed, so there is no problem to operate equipment there. There is another question of interference, which is probably related to performance, but the spectrum, as the spectrum is available. On the license bands, the spectrum is not available. We've seen a bidding war between Verizon and AT&T, where Verizon overbid AT&T, trying to acquire a spectrum holding company and some other company and tower companies that have licenses in 28. They paid probably more than $5 billion to get access to the spectrum. And actually today, 55% of licensed millimeter wave spectrum is controlled by Verizon. FCC is going to introduce the rest of the spectrum, or the leftovers of the spectrum, probably in 2019. The problem with that is the costs will be very high, and also it will not be sufficient to provide the desired degree of coverage. So license millimeter wave spectrum, if you are medium-sized service provider, is probably not accessible for you. And 60, 70, 80, 60 is unlicensed. There is 14 gigahertz of unlicensed spectrums. By the way, 14 gigahertz of unlicensed spectrum, it means that it is more than all other bands put together. And it is free of charge, no license needed. You have a customer that you'd like to connect, you just go there and connect. And 70, 80 gigahertz, it has 10 gigahertz of lightly licensed band. So from the licensing perspective, the procedure is very simple. Everything is online, and within overnight you usually get the license. The cost of the license is $75 per 10 years, which is really negligible. So and you gain all the benefits of the license spectrum. So you're protected. If someone else wants to deploy equipment, there is a coordination procedure, but the coordination and all this process is very simple because of the physics of this band, and therefore the spectrum is available, and any service provider here in the United States can take advantage of that. So if we sum it up, it seems like the millimeter wave bands of 60 gigahertz and 70, 80 gigahertz are the best technology for the fixed wireless applications. Now, So we understand the business case, we understand the underlying frequency, the technology, the main technology here. And now let's talk about the solution concept. So as you probably know from your experience, there are a lot of use cases for a fixed wireless access application. So in some cases, if you connect a single home, the capacity requirement may be 100 meg. If you connect an MDU, the capacity requirement may grow to 10 gig per building. The installation scenarios, so in some cases, you need to install at the tower. In some cases, you need to install at the pole, at the street level. Some cases, it is a single family home. Some cases, it is rooftop of MDU. Some cases, it's plaza. A lot of scenarios. The distances also may vary. We see distances, something that can be close, very close, 100 feet up to several miles. There are also some different interfaces, fiber, copper, different network topologies. Some use cases will require point-to-point. Some use cases will require point-to-multipoint. At some places, you'd like to have networking, aggregation networking. In some cases, you'd like to have equipment that is more optimized for access. So there is no one size fits it all. You need to think about fixed wireless access market as a number of different scenarios, and it means that you need to have, instead of having a single radio, you need to have really a solution. So it goes back also to the business case. You don't want to push a 10 gig radio to serve single family home, because the business case will not work, because probably the 10 gig radio will cost more than the radio that can provide 1 gig. Okay, and here I think this is one of our strongest points here in Siklu, that we have different product lines. We have E-band product line, we have V-band product line. On the left hand side, this is our E-band product, and as you can see from the form factor, it can go to the rooftop installation or the tower installation. We have one footer, we have 2 feet antenna as well to go to longer distances. We have different radios from 1 gig to 10 gig. And this is very important, because this radio, for example, is not suitable for street level deployment because of the form factor. And for the street level deployment, we have this one in the middle. It's 6 by 6 inches box, really designed for the street level. It has a lot of bells and whistles to make the installation at the street level very simple and straightforward, PoE in and PoE out, to minimize number of cables. But it's not, it works in point-to-point topology. Now, on the right-hand side, we have a product that is really optimized for single-family homes, which is point-to-multipoint, and can serve multiple homes and can make the business case work for this scenario. So this is a snapshot of our product matrix. As you can see, we have a mix of different products, and this is very important. This comes back to a solution concept. Okay. Next topic is the labor cost. From my experience working with the working with different service providers and that use this technology. In some cases, labor cost is the major component in the business case, and it's important to understand the technology, and it's important to understand how do you talk with the installers in order to explain what this technology is about, how does it work in order to drive this cost down, because once again it can be a major component. It can ruin the business case. So first of all, it's not a rocket science to do the installation. So in order to install this radio, and we are talking about 60 and 70, 80 gigahertz, there is no need in licensed tower climbers, someone that is licensed to do microwave installation, because most of the installs are done on the rooftops or poles or a single family home. So there is no need in licensed installers that are licensed to do that installation on the towers. This is one. The second is that the installation is pretty simple, because the distances are usually pretty small, within, let's say, 2-3 miles for the E-band equipment, within half a mile for the V-band equipment. It is more like a Wi-Fi kind of experience rather than traditional microwave. As you can see here, the equipment is pretty small. You can this is the 1-foot dish radio. It's even smaller than the DirecTV antenna, typical DirecTV antenna. So the installation itself, once you need to be familiar with the installation procedure. We have movies, we have tools in order to simplify that, and you need to explain it to a subcontractor if you use a subcontractor, or to your team, that the installation procedure is simple. We also have a lot of features inside the radio, inside the equipment, both on the mechanical side and on the software side, how to simplify the installation. We have a dedicated installation mode with the increased sensitivity. We have optical tools. We have some features on the mechanical brackets that all their intent is to simplify the installation and allow simple labor to simple installers to be able to install those radios. Now, next question is, assuming that the installation is simple, you may decide what to do in-house and what to outsource. Usually when you outsource the installation, you'll pay an arm and a leg for that. But thankful to a simple installation procedure, you may consider to do it by yourself. And we have several service providers that used to outsource all their installation work. Now they started to do some in-house installs, and it significantly reduced their expenses. When you still decide to outsource, you're better off talking about project approach and not onesies or twosies, and not about single installation. It means that if you want to cover a neighborhood, you'll come up with a plan, and that will include, I don't know, 10, 20 homes, and you'll ask a subcontractor to quote an installation work based on this plan, and not just a single install here and there. And this will save you a lot of money as well. Use local subcontractors. You can do a site survey by yourself. We have checklists and we have procedures that will help you to answer 90% or to cover 90% of the issues that may come up with when the installation takes place. And doing a site survey and filing this report and doing this checklist will help you to better negotiate with a subcontractor that will do the installation, because you already done your homework and you already seen the property and you know what's going on there. So make it a win-win for you. If you hire a subcontractor, you can go to the project approach, and it will help you to lower the labor cost. And for the service, for the subcontractor, it will help to win a sizable project. So it's a win-win for both sides. Next one is, so it was about the labor in general. Now let's talk about the truck rolls. And the truck rolls, it really comes down to how reliable your network is. So when it comes to reliability, there are several aspects that are related to technology. First of all, when you start rolling out the network, you'll probably experience lower take rates at the beginning, but then the network starts to grow, and you need to choose the technology that will enable you this growth, both in terms of network reliability and in terms of providing more capacity when it becomes necessary. So millimeter wave is a technology that actually can give you both. It is a virtually immune to interference, and this is because of the physical properties of this band. The antenna beamwidth is very directional. It is less than 1 degree, comparing to more than 10 degrees in the sub-6 band. And it means when network grows, you still have those pencil beam antennas that will not interfere one with each other. Now, we've talked about spectrum, and we've talked about the fact that there is a huge amount of spectrum available, and this huge amount of spectrum results in two things. One is the ability to deliver gigabit or multi-gigabit capacity. As you've seen, we provide today equipment that can scale up to 10 gigabit per second, full duplex. It means 10 gig up and 10 gig down, and we are working on the next generation product that will deliver even more bandwidth. And the other thing is that there are multiple number of channels, and multiple number of channels gives you the flexibility to build dense networks, and also to mitigate the risk of interference, because you can switch to different channels. For example, our V-band radio, it supports I think 13 non-overlapping channels in the current version. So millimeter wave as an essential technology here, it provides you the capability of delivering the gigabit speed without without risk of interference, and it means that when network grows, there will be no truck rolls just to deal with those interference issues. Another point is to build a reliable network topology to take advantage of different networking features that will enable that will build in the resiliency into your network design, and we'll talk about that in the next slide. And also, last but not least, and actually this is probably the most important thing, is don't compromise on quality. And quality, it means that there are different vendors, different suppliers, and choose carrier-grade technology. Carrier-grade technology, it means that the vendor goes through the quality assurance procedures and quality control procedures to make sure that the equipment actually complies to a specific standard. It means that the vendor chooses the right components in terms of the temperature grades, in terms of the quality, in terms of different suppliers, in terms of suppliers' qualification. And at the end of the day, it results in MTBF. So when you choose the equipment for your network, probably from the reliability perspective, the most important thing to look on is the MTBF. In some cases, the number itself is usually based on it can be based on either a calculated model or field statistics, and it is very important to ask the vendor how did he calculate this number, because if it is based on a model, it means that the vendor is not experienced enough, and the technology is not field proven, and probably not reliable enough, not baked enough to serve as an essential part of the network. And you need to ask for a high number that will tell you that the technology is proven, and the number and the MTBF calculation should be field proven and based on the equipment that actually installed at the field. Now, last point here is I've mentioned the advanced networking, and here is an example. Our equipment supports Ethernet ring protection, and using just our gear, and this is a standard protocol. This is a standard Ethernet protocol. You can build rings, and it means that without any additional networking gear, you just utilize the feature that we have in most of our equipment that is designed for the backhaul or for the core of the network. You can use this feature and build a network that has no single point of failure. And it means that if one location has a malfunction, either on the power or on the equipment side, or something went wrong, all the rest of the network will perform as designed, and there will be no effect on the service delivered to the rest of the network. So we have several examples here. On the left-hand side, this is a network we deployed in single-family homes. On the right-hand side, this is a network, a ring that we deployed in a metro area in MDUs. This one is in Cleveland, and you can see that actually there are two rings. This is one ring, and this is the second ring, and there is resiliency and redundancy there. So this is a kind of advanced topic, but this is something that can really help you with the maintenance of the network, because if you in such a design, if you have a malfunction, there is no need in running and fixing it right away, because the rest of the network is not affected. Now, last topic is advanced tools, and in this regard, we based on our experience working with different service providers, we realized that one of the main challenges is actually the design and the planning of the wireless network, because there are, as we've mentioned, there are a lot of use cases. There is a lot of scenarios. There is a lot of applications where the operator needs to choose the right tool, the right technology from the solution portfolio. And we have a tool that is called Windy that actually automates all the planning and all the design of wireless network, and help you as a service provider to come up very fast with the network design. If you are an integrator, you can use this tool to submit proposal. It generates the network topology, it generates bill of material, it generates configuration files for the equipment. So this is a tool that we have. We don't have much time here to go in deep how this works. I'll distribute we'll distribute the slide deck. You can go either to our site or to the link here and ask for a demo. We'll do a dedicated session with you and show you how this tool works. We have a series of business case tools. So here is a link for an MDU business case. where you can plug in the numbers and you can calculate the business case to see the KPIs. And it is something that will help you very fast to assess the opportunity to see whether it makes sense or not. And we have a link budget calculator to calculate the performance of the radio and see what distance, what performance you'll be getting. So putting it all together, we've talked about the right technology based on the KPIs to be the basic technology for fixed wireless access, and it is millimeter wave 60, 70, 80 gigahertz. We've talked about the importance of solution. That there are multiple use cases, multiple scenarios, multiple installation scenarios, and we in Siklu provide you a complete millimeter wave portfolio that you can choose from. We talked about the importance of understanding the labor cost and how you can significantly drive this labor cost down. Build to last, choose the carrier grade equipment, high MTBF, field proven, and also take advantage of planning and design tools to scale and to overcome wireless network design challenges. So this is it on my side, and I'll open it up to questions. David.
Sure, thank you, Boris. That was very illuminating. We do have some questions that have come in. I'm going to start with probably the most common one that everybody's thinking about. And you talk about the millimeter wave. Is this a line of sight solution? What do I do about residential areas with mature trees?
Yeah, so yeah, it is a line of sight technology, like all the technologies from starting from 6 gigahertz and up. And there is LiDAR data that is available to plan the network, and we can take it into account in our planning tools. But yes, this is a line of sight technology.
Okay, another question that we've received: how do I manage this network? I have a management system in place. I mean, I've got to fold this into my bigger network. How do I do that?
Yeah, so all our equipment is on the networking side. We follow standards, and we have SNMP interface, and we provide MIB file with each and every release. And usually what service providers are doing, they integrate our equipment into the existing network management system and use this MIB file. We'll start offering EMS also to manage Siklu radios, and we'll announce it probably during the next couple of weeks.
Okay. Another question we have. So you talked a little bit about the labor costs on the installation, but what can I as an operator expect in terms of maintenance costs for this network? You know, equipment failure, weather events. What's it going to cost me outside of my labor? What's it going to cost me to maintain this network?
Yeah. So once again, if you choose the right vendor, if you plan it right, the maintenance cost is very low. We have for example, the slide I showed with this mesh network in a single-family homes neighborhood. It was deployed 2.5 years ago, and the service provider that deployed that actually said that it is the most reliable network that they ever deployed, and they have tens of thousands of customers. So when you choose the right equipment, when you plan the network right in terms of choosing the right gear to serve the right application, understand the trade-off between the availability and the distance. It is here to stay, and you put it once and it will stick forever.
Okay. And next question we had was, who is the customer? Is it the homeowner or the building landlord or the building owner? Who am I? Who's my customer?
Yeah, so our customer is service. So we sell the equipment to service providers, and they use this equipment and they sell their service to it can be building owner in cases of MDUs. It can be business. It can be single family. Single person.
Okay. So the next, I have a couple of questions for us. I'm going to kind of group them together here. There's questions about CBRS, which is the 3.6 gig. There's LTE. How does this solution compare to the CBRS and the LTE?
Yeah, so first of all, there is still uncertainty in terms of licensing for the CBRS, and it's not clear whether probably the big guys, the big service provider, that they will get some chunk of the spectrum, but still it's not clear if you're a medium-sized service provider what spectrum will be available and what's going on and how much of the spectrum is actually going to be available. Now, it is a low band, it's still low frequency, and it means that the channels are narrow, and it means that still you'll not be able to deliver gigabit service. Now, it's not a Wi-Fi technology, so once again, I'm referring to the KPIs that I've described. So availability of spectrum is something that is uncertain. Capability of performance in terms of delivering hundreds of megabits or gigabit per second, this is probably will not be achievable because the bandwidth that is available in this 3.5 band is not enough to deliver such capacity. And the business case, once again, the question is what will be the cost of the equipment, what the background technology will be used there, and in this case, more important, what will be the cost of the central office? Because if in order to deploy CBRS, if you need to put together an LTE core, it will probably cost you an arm and a leg.
Okay, we have several questions about the availability of the slide deck, so I'll just repeat that here. We will make this slide deck available after the webinar, so you'll all get a copy of this. We are running out of time. We have a ton of questions. I apologize if we do not get to your question. I'm going to try and pick, I think, the most relevant ones for the audience. There's a little confusion for us about chipsets and protocols and the E-band and V-band products. What's WiGig? What's not WiGig? Can you maybe clarify that a little bit?
Yeah. So yes. Our E-band point-to-point is based on a combination of off-the-shelf components and something that we developed by ourselves. And this is a point-to-point technology, it's not related to WiGig. Our 60 gigahertz product line, we have two products. One is the point-to-point, which goes to longer distances, which is based also on proprietary technology. And the point-to-multipoint is based on the WiGig. Now, when we talk about WiGig is the background, is the basic technology that we use. And WiGig as a technology was developed for indoor use cases. So our secret sauce was to take this indoor technology and to make carrier grade outdoor products using that. And it means that we need to the reliability criteria that was used for indoor products is not the same for outdoor products, right? Distances also for indoor, it's probably good to have a connection for up to, let's say, 10 meters, 20 meters, right? For outdoor, 10 meters is not acceptable. So we took this WiGig technology as a background and developed our secret sauce, our antennas, our features, our networking around that, and made an outdoor product. So currently, our point to multi-point product is good for distances up to 1,000 feet with 4 nines availability. It supports, one sector can support up to 8 clients. It has fiber and copper interfaces, etc., etc. So this is, I think, this is the background.
Okay. Well, I think we've run out of time. I appreciate everybody hanging on to the end. We will take all the questions that we've received, and as part of the follow-up, we will reply to them in a written document. So if I didn't address your question today, we will definitely get to it. Again, appreciate everybody taking their time out to come join us today. And Boris, thank you very much for a job well done.
Yeah, thank you very much for attending this webinar, and thank you, David, for the introduction and for the summary.
All right. Bye, everybody.